Alright, this is the last day of section 4.1. What we're going to do today is look at some acceleration, velocity type problems. So this one says use A of t equals negative 9.8 meters per second per second. So that means meters per second squared is the acceleration due to gravity. So let's go ahead and start with that. And what I'm going to go ahead and do is write down that A of t is equal to negative 9.8. The Grand Canyon is 1,800 meters deep at its deepest point. A rock is dropped from the rim above this point. Write the height of the rock as a function of the time in seconds. So basically, we're being asked to find the position function. You could memorize the position function as I've stated before, and we could get directly to the answer. But I'm going to show you how you can use integration. So you don't have to memorize that. So when you integrate this with respect to t, we would get back to the velocity function. And so our velocity would be negative 9.8 t plus c. Now, we do know that the initial velocity is 0. We know that because we're standing there holding the rock. So that means at time 0, the velocity is 0. So I could plug in 0 and 0 so that I can find c to be 0. So what that means is my velocity function is just simply negative 9.8 t. I don't need to put plus c because it would be plus 0. So the next thing I'm going to do is go ahead and change this, and I'm going to integrate it so I can find the position function. So I'd get negative 9.8 t squared over 2 plus c. Now in this particular part, we know that the initial position is 1,800. So at time 0, okay, this is actually negative 4.9, plug in 0, we get c to be 1,800. So my position function is s of t equals negative 4.9 t squared plus 1,800. So that's one of my solutions. The second part they want me to do is find out how long it will take the rock to hit the canyon floor. So that means that we're going to take our position function and we're going to set this equal to 0. Because we want to know at what time will the position be 0. So when we solve for this, we can bring the negative 4.9 t squared to the other side. We will divide by 4.9. So we have 1,800 divided by 4.9. And then what we're going to have to do is square root that. So t ends up being the square root of 1,800 divided by 4.9. That's the time at which it takes for the rock to hit the floor. Let's try another one of those. So once again, I'm given that the acceleration is negative 9.8 meters per second squared. And this time I know a baseball is being thrown upward from a height of 2 meters with an initial velocity of 10 meters per second. So I know that at time 0, the velocity is 10. And I also know at time 0, the position is 2. So we use both of those to come up with our position function. Now, if you remember the formula, s of t equals 1/2 g t squared plus v sub 0 t plus s sub 0, and I could have done this on the last problem as well. I can get directly to the answer. I can just say it's 1/2 of the gravitational pull, negative 9.8 t squared, plus my initial velocity, 10, plus my initial position. And most of the time, people are not memorizing this or remembering the formula, so they aren't able to do it in this method. On the next video, I'll show you how you can use integration to come up with the same solution. So in the last video, I was just showing you how you could come up with this position function rather quickly, not using any of the integration methods. But I'm going to go ahead and do that now. We're going to use integration. We're going to start with the acceleration, and I'm going to come up with the velocity function by integrating it. So I get negative 9.8 t plus c. I know the initial velocity is 10, so at time 0, I get 10 for my velocity. So that makes my velocity equation be negative 9.8 t plus 10. Now, by integrating my velocity, I can get to my position function. So I have negative 9.8 t squared over 2 plus 10t plus c. So I end up getting negative 4.9 t squared plus 10t plus c. I know my initial position is 2, so when I plug in 2 and I plug in 0 for all my times, I get my c value to be 2, and therefore I get the same answer I just got using the formula that we memorized earlier this year, or you might have memorized at some other point in time. The actual question in this problem says, determine its maximum height. Well, in order to determine its maximum height, we're actually going to have to figure out where the velocity equals 0, because when we once it's at 0, then it means it's going to come back downwards. So we're going to actually look at the velocity here, and we're going to set velocity equal to 0. So I have this formula. I knew that the initial velocity was 10. I should have actually brought it from right here. When we bring the 9.8 t to the other side and I divide by 9.8, I get 10 divided by 9.8. So the time at which this happens is approximately 1.02 seconds. So what that's going to allow me to do is now take this time and plug it into the position function. So I can figure out what is its maximum height when does that occur? Well, we know when it occurs. It occurs at 1.02 seconds. But what is that actual height? And I'm not pulling up a calculator to do this. You guys can check it on your calculator, punch everything in. You should get the approximately, when you square the 1.02 times the negative 4.9 and add it to these other items, you should get at 7.1 approximately, and that'd be 7.1 meters. Is where the maximum height occurs. I have one more of these examples, and what we're going to be doing with this is it says that consider a particle moving along the x-axis where x of t is the position of the particle at time t, and x prime is its velocity and x double prime is its acceleration. A particle moves along the x-axis at a velocity of 1 over the square root of t. So this is the square root of t, where t is greater than 0. At time equals 1, the position is x equals 4. Find the acceleration and the position functions. So let's go ahead and just start with the equation that they give me. V of t is 1 over the square root of t, so let's shift t to the negative 1/2. I'm going to do the easy part first, which is just the acceleration. The acceleration is just its derivative. So when I take the derivative, I get negative 1/2 t to the negative 3/2. So I can rewrite my acceleration as the square root of t cubed, negative 1 over 2 the cube root of the square root of t cubed. The position function I will have to figure out or finish up on the next video. Alright, getting ready now to, after I found the acceleration function, I'm going to find the position function for this particle. So the position function we're going to get to by integrating. So I'm going to raise this by 1 and put it over that power and put plus c. And then I'll go ahead and rewrite this. So it would be 2 the square root of t plus c. Now they do give me some numbers here. So at time 1, so when t is 1, I know its position is 4. So I'm going to have the value of 2 for my c, and that allows me to write my position function as 2 square root of t plus 2. And I'm finished with both of those parts.